Hi, my name is Emerson Franks, and I'm the Data and ML Infrastructure Lead at Rec Room, and I've been here for just over 2.5 years. Before joining Rec Room, I led the Services, Data, and Live Ops teams at Turn 10 for almost 4 years, and I started my career as an engineer in the online services org at Microsoft. In this discussion, I'm going to walk you through our data infrastructure here at Rec Room at a high level, how we have Prefect set up, how we're leveraging Prefect and DBT, among other tools, to build robust ETL pipelines, and a couple of our primary data flows to provide some concrete examples of how we pull all these tools together. So jumping to talking about the data infrastructure. Rec Room's data infrastructure has evolved significantly since I first joined. When I arrived, we were syncing data from our databases using Fivetran with SQL change tracking. The data was pushed into our lake, which at the time was a Hive metastore. But in our quickly evolving data infrastructure, this soon changed, and we migrated all of our data to Unity Catalog to leverage the latest Databricks tools. I have to say this was not a quick and easy migration. Initially, we used the data to build player insights and build analytics for the business, but quickly began tackling more advanced tasks like rankings, recommendations, and using things like hot scores. These started as simple Python jobs running in Databricks workflows, but evolved over time. As our data team grew, so did our tool set. Our analytics engineering team was using DBT for ETL. In addition to the SQL syncs, we had Databricks workflows for batch processing, and we're continuously ingesting data that was coming through on our data collection streaming job. On the consumption side, we started using the Databricks feature store, doing online and offline inference, and building dashboards in Hex and Sigma. With more tools involved in our data processes, efficient coordination became really crucial. After evaluating orchestration tools like Astronomer and Dagster, we chose Prefect for its flexibility and reasonable cost. Prefect has since become the backbone of our data architecture, orchestrating all of our processes. So what does this look like for our setup? It's actually pretty straightforward. Our Prefect code runs in Azure and runs on Kubernetes through AKS. And we're still using the free tier of AKS. We only run 2 environments, dev and prod. This setup has been both cost-effective and scalable and allowed us to keep our monthly run costs right around $500, with most of that going to the standard D4 ADS v5 VMs running the workers and jobs. We do leverage auto-scaling, but for the most part, we tend to not need it and just run with the basic setup. Our pods use custom Docker-based images, which we push to our container registry via our CI/CD pipeline. This pipeline is managed by Azure DevOps with our code stored in a Git repo. We follow a simple branching strategy that allows developers to quickly deploy code to Azure running during development while ensuring security in production deployments. An engineer can deploy to dev at any time by creating a PR that would merge back into production. That PR must be reviewed and approved by a member of our server team before it can be merged into production. Once merged, though, an additional approval step triggers the final deployment to production. Next, let's talk about how we're leveraging Prefect to orchestrate our DBT CLI-based ETL. For the DBT flows, we use the Prefect DBT Python package, pinned to a specific version to avoid unexpected updates. Our DBT ETL code lives in a separate repo from our Prefect code, allowing analytics engineering to iterate freely without affecting Prefect-related work. One of the most interesting aspects of our setup is how we've managed to dry up our code for Databricks, DBT, and Fivetran flows. Instead of creating one flow per DBT run manually, we use a configuration file. Analytics engineers simply add a JSON object to this file, which is then used by our dispatcher and FlowFactory to generate flows during the Prefect deployment process. This eliminates hundreds of near identical Python files in our repo. All our AEs have to do is update the config and create a PR. The PR triggers the deployment process that we discussed above with separate config files for each environment to avoid any issues. Once deployed, we use automations to orchestrate flows. Internally, we've built a dependency tracker to visualize the dependency tree. This helps our data infrastructure and AE teams to understand the impact of any changes on the automations. These automations keep our pipelines running efficiently, ensuring DBT and other flows don't run if data quality or freshness checks fail. The tests can be run with a simple dbt CLI command that is its own flow generated by the configuration file. Our primary pipeline begins with data quality and freshness checks, followed by the core ETL. The flow spawns hundreds of flows that handle everything from additional DBT model building to Databricks workflows or batch processing and training and inference. Each flow is tagged to notify the proper team via Slack or PagerDuty if the flow fails. In general, we tend to lean towards Slack rather than Pages, unless the flow is deemed critical to business operations and needs to be repaired as soon as possible. Jumping over to the data flows, we really have two core types, streaming and batch. There are other flavors that have slight variations, but these two highlight most of the processes and tooling that we have in place. The streaming path consists of events being sent to an API that is mostly just a pass-through onto an event hub. There are features in the service to allow sampling or disabling of an event, but we really try to do as little as possible before putting it on the hub. From there, a streaming Spark job running in Databricks workflow continually grabs batches of messages and inserts them into a table in our lake. Again, at this point, no transformation. We're just putting the events into a single table where they're later processed by the ETL. The only thing we're doing at this point is partitioning the events by date and event name. During the ETL, we leveraged a DBT profile feature that allows us to use different serverless warehouses for different commands, thus allowing us to use bigger machines when the workload requires it, or much smaller ones where we can try to save money. With the data in the intermediate layers, we run batch processing, model training, inference, and other jobs. Some of these jobs end up pushing that data back to the server where it can be made available to the client. Now let's jump to our other process that helps us manage costs. While streaming is great, it's not cheap. To help manage costs, we also leverage offline batch processes. For this data flow, we pull data from servers, databases, or external sources and push it into our lake. This data flow was one of the first we set up, but because we didn't have orchestration to begin with, it was more of a guessing game as to when we should run the jobs. Adding Prefect fixed that and allowed us to do much more interesting things. For many of these ingestions, we use Fivetran, but we also use function apps or API calls within the flows. From there, it's largely the same as the streaming process that I explained previously. We use DBT to do the transformation and table building, and Prefect orchestrates flows that kick off model training, inference, and other jobs that will at times push data back to the server. Well, that's our story. While it's not overly complex, using Prefect alongside tools like DBT, Databricks, and Fivetran has allowed us to accomplish some exciting things. As we move forward, we plan to add automations into our FlowFactory, and we'll look to make the dependency graph a part of our CI/CD to ensure that our pipelines are never inadvertently broken and harden the overall process of taking code and getting it into production safely and efficiently. Thanks.